Today, we are going to see some more interesting and important questions from previous year questions. Mole concept. Come on, let us discuss the first question. The number of moles of KMnO4 reduced by 1 mole of Ki in alkaline medium. That means how many number of moles of KMnO4 reduced by 1 mole of Ki? That is the question in alkaline medium. Come on, when we are writing the balanced equation, it will be easy to identify which is the correct option. So here K MnO4 plus what it is alkaline medium or in what it is potassium iodide. So OH minus alkaline medium. So you are getting here MnO2 plus potassium hydroxide plus KiO3, that is potassium iodide. Okay, now let us balance that equation here. MnO2, it is there potassium hydroxide and potassium iodide. So here let me put it here too. So when we put it here too, 2 plus 1, 3 potassium is available, and manganese 2, oxygen 8 is available. Okay, let me put it here too. Why? Because manganese, here manganese, yes. So how many oxygens here at present? Here 4 oxygen, and here in this potassium, how many? Here 3 potassium is there. Okay, let me put it here too. So that means 3 potassium. So 2 plus 1, 3. Yes. So then how many oxygens are available here? Here 8 plus 1, 9 oxygens are available. So here 4 plus 2, 6 plus 3, 9. Yes, iodine 1. Yes, balance that equation. Now, let me identify how many number of moles of potassium permanganate in potassium iodide. So here 2 moles are available, 2 moles of KMnO4 reduced by 1 mole of potassium iodide. So that means here how much number of moles required. So 1 mole of Ki reacts with 2 moles of KMnO4. So the number of moles of KMnO4 reduced. So the number of moles of KMnO4 reduced is how much? 1 mole of Ki in alkaline medium is 2 moles of KMnO4. So this is 1 mole and this is 2 moles. I hope you got that idea. So which is the correct option? 2 is the correct option. I hope you got the very clear idea to identify which is the correct option. Option B, 2 is the correct option. Yes, come on, let us go to the next question. Mass of carbon anode consumed giving only carbon dioxide in the production of 270 kg of aluminium metal from bauxite by the whole process as what is the correct option? Let us discuss here. Mass of carbon anode consumed giving carbon dioxide, the production of 270 kg of aluminium. This is like 10 apple cost this much. That means 1 apple cost how much? Just the opposite, like that way. Here they have given that idea about 1 apple cost. Now we have to identify the 10 apples. That is what here 270 kg of aluminium. How much? Like that. So atomic mass they have given. Well and good. Okay, come on. Let us write the chemical equation so that it will be easy for us to understand. Yes, aluminium oxide, no, that is bauxite. So here what it is? Al2O3 plus carbon, that is anode, consumed here what it is? Aluminium plus carbon dioxide. So balance that equation. Here 2 moles of aluminium require 3 moles of carbon. Okay, now here what it is? 4 moles of aluminium, here 4, and oxygen how many? Here 3 carbon, and oxygen here 6 is there, no? So here what you will get it? You will put it 3, so that you will get what it is? 6 oxygen it is there, 3 carbon. Yes, it is balanced. So now let me write that idea about what it is, molecular mass, so that you will come to know the clarity. So here what it is? 3 moles of carbon. So that means 3 into 12. How much it is? 36 gram per mole, right? So 36 gram per mole of carbon produces 4 moles of aluminium. So 4 moles of aluminium, how much it is? 4 into 27. So altogether how much? 4 sevens are here. Yeah, sorry. 4 into 27 here, 108. Right. So 108 gram per mole. right? Okay, so 3 moles of carbon can produce 4 moles of aluminium. That is 36 gram of carbon can produce 108 gram of aluminium. So that means here 270 kg of aluminium can produce how much mass of carbon? That is only the question. I hope you got the clarity. Come on, let me write this point for you. So 1 gram of, that is, yeah, I just mentioned here, 1 gram of aluminium can produce from the mass of carbon, right? So here, how can you bring this here? 1 gram, I just mentioned here, it is 36 by 108. Okay, 36 is what it is? 3 moles of carbon. And here what it is? 4 moles of aluminium. Therefore, here, what I can include in this? Therefore, 270 kg, that is what in the question it has mentioned, 270 kg of aluminium can produce from the mass of carbon. How much mass of carbon required? So cross multiplication, simple. Always you just go for cross multiplication. Here here what it is, 36 divided by 108 into 270. So an element X has following isotopic composition: X 200, that is 90 percentage, X 199, that is 8 percentage, and X 202, it is 2 percentage. The weight of average atomic mass of naturally occurring element X is closest to 2. So which is the correct option according to this question? So this is actually what it is, average atomic mass. That is what we are going to conclude, this average atomic mass. Now, first and foremost, let us write the data so that it will be easy for us to understand. So, X is an element. Here, 200. First 200 they have given, right? So, X 200, how much percentage? It is 90 percentage. So, in that way, here 90 by 100. So, how much you will get it? 90 by 100, no? So, that is 0.9. Right? Okay. And the next one here, X. How much? The second one, 199. 199, how much percentage here? 0.8 percentage. So here 0.8 means 0.8 divided by 100. So how much it is? 0.08. And third one, how much? Here X 202, how much percentage? 0.2 percentage. That's what here they have given. Yes, so 0.2 divided by 100, how much it is? Here 0.02. Now this is actually mass of each isotopic, it's fractional. Correct. Okay, so fractional abundance. So this is first point here, 200 into 0.9. The second one, what it is? 199 into 0.08. Third one, 202 into 0.02. So how much you are getting here? So here you are getting, when you calculate it, two nines are, yeah, 18, right? So 180 you will be getting. So 180, right? Now here you will be getting what it is, 8 into 199. So here you will get what it is, 15.92. And the next one here, what is the answer you will be getting? Yeah, 2, no, 2 into 4, 0. Okay, so that means here 4, not 2, 4, not 4, right? 4.04. So all together when you calculate it, so here what are the points? 180 plus 15.92 plus 4.04. So altogether you will get how much? You will get around 199.96. Right, so approximately it is around, complete a whole number, it is 200. Shall we write it 200? Right, 96.996, right? So that is 200 AMU. Okay, so average atomic mass, which is that average atomic mass of element, it is 200 AMU. So which is the correct option? Yes, which is the correct option? Option D. Yes. Option D, it's blinking here. Yes, I am here to find the answer. Yes, here. So 200 AMU is the correct option. So before finding the option, you should know how to solve the problem. So the answer will be there for it to understand. Yes, come on, let's go to the next question. Here 36 ones, 36 2, 36 3, or 108. Okay, 36 3, here we just put it 3, right? So here 3 ones are 3, 3 nines are 27, 9 and 0, so that means 90 kg. So here what you're getting, 90, so kg. So what is the point I just wanted to bring? The mass of carbon anode consumed for 4 moles of aluminium. So the mass of carbon consumed for 4 moles of aluminium in Hall's process, it is 90 kg. Now come on, let us check the option which is the correct option. Yeah, here it is blinking, the answer, it is blinking. C is the correct option. Option C is the correct option, 90 kg. I hope you got that idea. How do we go for it? Generally, all the questions from generally physical chemistry, logical way thinking only. So if you have that presence of mind and logical way thinking, you are able to handle that answer, that means question, very well. Yeah, come on, let's go to the next question. Volume of oxygen gas O2 measured at 0 degrees Celsius and 1 atmospheric pressure is needed to burn completely 1 liter of propane gas, that is C3H8, measured under the same condition, temperature and pressure they have given, right? Okay, see, generally this hydrocarbon combined with oxygen, combustion equation only. So you know very well, last previous video also I just mentioned, right? Come on, let us write that combustion equation of propane combined with oxygen. So propane C3H8 combined with oxygen, you are getting carbon dioxide and water, that is mandatory. Hydrocarbon combined with oxygen, you are getting carbon dioxide and water. So here balancing equation, here 3 carbons are there. So 3 carbon dioxide, here 8 hydrogen it is there. 8 hydrogen means that is y by 2. So that means 4 hydrogen, so 4 2s are 8. Now here how many oxygens are there? So from here only we can balance, that is another one way we can conclude. Okay, so how many oxygens are there? Here 6 oxygen, here 4. 6 plus 4, 10. So here 5. So 5 2s are 10. Yes, we got it. Okay, now according to this, for this question to deal, we can take Avogadro's law. What is it, Avogadro's law? Here under the same conditions of temperature and pressure, same conditions of temperature and pressure, equal volume of gas contains, equal volume of gas contains, that is equal number of moles, equal number of moles. That's all. Easy logical way thinking. So here what it is, 1 mole of what it is, propane gas required 5 moles of oxygen to burn completely. So that means how much liter required to completely burn? That is what the question. See here, needed to burn completely 1 liter of propane gas. How much, what volume of oxygen required? See, there is a question, there is the answer here. 1 mole of propane gas required, 5 moles of oxygen to burn completely. You're getting carbon dioxide, water. So here what is the answer? Volume. Here volume is equal to number of moles. Number of moles, simple. Avogadro's law. Avogadro's law. So here what it is? So 1 mole of propane. So that is 1 mole, 1 liter. I just mentioned here 1 liter of propane. Completely to burn. Completely to burn. 5 liter of oxygen required. Right? Got it? So what is the answer? 5 liter. So 1 liter of propane gas required completely to burn 5 liter of oxygen. I hope you got the clarity. 5D option is the correct option. Yeah, come on. Let us go to the next question. See, some questions and all, you no need to break your head. It is very simple. Logical way thinking, presence of mind. Read the question carefully. You are getting the answer on the way. Come on. Let's go to the next question. In between 6.5 gram of PbO and 3.2 gram of HCl. Now from this question, you are able to identify that what it is. 2 points. One thing, you will find the number of moles. Why? Because they have given mass. So given mass by molecular mass, number of moles only. So if you write that balancing equation, so you will come to know that clarity. And second point, you have to identify limiting reagent, right? So these are the 2 main points from that we have to identify. Why? Because how many number of moles of lead chloride will be formed? So lead chloride formed, that is the product. This is the reactant. So let me write that equation so that you will come to know the clarity. So here PbO, this is PbO plus HCl. You are getting PbCl2 plus H2O. So PbCl2 plus H2O. No. Now balance that equation. PbO, Cl2. Cl2 means here only we have to put it 2. So that means H2Cl2. Yes, it is balanced that equation. Now here 1 mole of PbO requires, that means 1 mole of PbO combined with 2 moles of HCl. You are getting platinum chloride, that is PbCl2 plus water. Okay, now let me write that molecular mass. So here, because given mass they have given, molecular mass will find out, then we'll go for number of moles. So Pb, how much it is? Actually 207.2 plus 16. So altogether 223.2 as a molecular mass of PbO. And of course HCl, you know very well, 36.5. This is gram per mole. Gram per mole. This is also gram per mole. Right. Now number of moles. Directly we'll go for it. So number of moles of PbO. It is given mass by molecular mass. Given mass, it is mentioned in the data 6.5 gram. Directly we'll go for what it is. Data, because given mass by molecular mass, that is number of moles. You know that formula very well. So 6.5 divided by 223.2. Just now we got it now. 223.2. So when you calculate it, how much you will get the answer. So make it a whole number while calculating so that it will be easy while doing that. So 0.0 you'll be getting. So while calculating, you will be getting 291 mole. Right. Okay, 291 mole. Yes. Now the next one, number of moles of PbOs. That's again one number of moles of HCl. Okay, let me write the number of moles of HCl. Number of moles of HCl. So number of moles of HCl, that is given mass, it is 3.2 gram. Yes, it's there. Divided by molecular mass, you know very well, 36.5 gram per mole, right? So you will be getting what it is, 0.0, right? 0.0, right? So 0.0, you will get the answer, 0.0877 already calculated. So I just mentioned here. So you just check it whether it is correct or not. Okay, now, so number of moles of PbO, that is 1 mole of PbO reacts with 2 moles of HCl, you are getting that number of moles this much, and you are getting what is the product? 1 mole of PbCl2 and 1 mole of water. Come on, now which is the limiting reagent? So limiting reagent is what it is, which is completely consumed. That is called a limiting reagent, right? So here 1 mole of Pb, 1 mole of PbO reacts with 2 moles of HCl. So that means here the required moles of HCl for 0. This is actually 0.0291. So the required moles of HCl for 0.0291 mole of PbO. So here what it is, let me multiply with 2 over here. So here 0.0582 mole. Right. Why we are multiplying? Here 1 mole of Pb reacts with 2 moles of. So that means here, what is the number of moles here? 0.0291 into 2 moles of HCl, that is. So you are getting what it is, 0.0582 mole. So, but here, how much it is actually, it is available in this. Here actually what it is? Here what it is, 1 mole, here 2 moles. So this is number of moles only we got it. So number of moles of Pb, this is 0.0291 into 2. So that means this is the answer you'll be getting. But actually what it is, you are getting HCl, availability of HCl. Availability of HCl. So how much it is? 0.0877 mole. Actually, how much we required? 0.0582. So that means which is what it is, limiting reagent. So this is actually limiting reagent. LR, it is a limiting reactant or limiting reagent. Right now, so PbO, it is a limiting reactant. So PbO, it is a limiting reactant, a limiting reagent, all are same only. So 1 mole, I just mentioned here clearly. So 1 mole of PbO requires 2 moles of HCl to give 1 mole of PbCl2, right? PbCl2. So that means 0.00291 mole of PbO gives 0.0291 PbCl2, right? PbCl2. See here, 1 mole of PbO combined with 2 moles of HCl, you are getting 1 mole. Here also 1 mole, here also 1 mole. You see, 1 mole of PbO can give 1 mole of PbCl2. That means 0.0291 mole of PbO can give 0.091 PbCl2. Only can provide. Yes, which is the correct option? Come on, let us go and find the answer in the option. Which is the correct option? Yes, A option is correct option. Come on, yes, I hope you got the clarity how to identify. So if you write that balancing equation, you are able to identify number of moles as well as limiting reactant and finding the answer. Come on, let us go for the next question. The next question, an organic compound contains carbon, hydrogen, and oxygen. Its elemental analysis gave carbon 38.71% and hydrogen 9.67%. And find out the empirical formula of the compound would be. Yes, we have to find the empirical formula. In that, carbon and hydrogen, they have given that, what it is, data. Oxygen, they did not give. So generally, what it is, 100% when we calculate all three. So let me write the data here. Carbon, how much? Carbon, it is 38.71%. Hydrogen, it is 9.67%. So when we add, you will get what it is here 8 and here 3 point, here what it is 48, right? So 48 you'll be getting, right? 48. So this is 48. So 100 minus 48, 100 minus 48.38%. So you will be getting what it is remaining 51.62% only oxygen. So we got all the data. So oxygen we got it, oxygen just now we got it, hydrogen and oxygen they have provided already. Okay, let me write the data here in this column so that easily we can identify. Now what are the elements? Carbon, hydrogen and oxygen. And atomic mass of carbon, it is 12. Hydrogen, how much? It is 1. And oxygen, it is 16. And percentage, how much they have provided? Here, 38 in the data. 38.71, right? 71. And hydrogen, it is 9.67. And oxygen, just now we found that is 51.62%. Already percentage, it has mentioned. Now, a percentage composition we have to identify. So, percentage divided by atomic mass so that you will get it. So, here percentage, how much here? carbon 38.71 divided by 12, and here what it is, 9.67 divided by here what it is, hydrogen atomic mass, just divide by. Okay, now oxygen 51.61.62 divided by 16. So you'll be getting the answer here 38.71 divided by 12. So you will get 3.22. You'll be getting the answer 3.22. And here just the same number only, 9.67, same number. And here this also 16 to table if you go. So 3.22 you'll be getting. Now simplest whole number ratio. Now which is the simplest whole number ratio? Which is the least one. Okay, so that is so here 3.22 divided by 3.22. So you'll be getting 1. And here 9.67 divided by 3.22. So here how much you'll get? 3 ones are the 3 3s are 9. So you will be getting what it is. Here 3 you'll be getting, right? Approximately. Okay, now here what it is, 3.22 divided by 3.22. So you will be getting 1. So carbon here 1, hydrogen here 3, and oxygen here 1. So here empirical formula only they are asking. They are not asking about molecular mass. Find out that n. No, nothing. So directly empirical mass. Empirical mass. Sorry, empirical formula. Formula only they have given, right? So empirical formula. It is carbon, hydrogen, oxygen. Carbon 1, hydrogen 3, oxygen 1. So CH3O. So this is the empirical formula. Right now, what is the answer here? CH3O. Where it is? CH3O. Option B. Option B is the correct option. What it is? CH3O is the correct answer. I hope you got the clarity. With this, it will be easy for you to understand. Yes, come on. Let's go to the next question. The next question, number of atoms in 0.1 mole of triatomic gas is. So they have given the option. See, number of atoms, if we want to identify, I would like to give that formula. So the number of atoms, the number of atoms equal to number of moles into Avogadro number into atomicity. Atomicity. What do you mean by atomicity? Number of molecules present. Okay, so the number of atoms present in the molecule, that is called atomicity, right? So here number of moles they have given here, the number of atoms in 0.1 mole of triatomic gas, even what it is, atomicity. Triatomic gas means what it is, 3 atoms together in that gas molecule. So that is called atomicity. So we got the values also. Come on, let us finalize the answer. So here number of moles, that is 0.1 into Avogadro number 6.023 into 10 to the power of 23 into atomicity. How much it is? 3. Atomicity 3. Triatomic gas, right? So that is 3. So when you calculate it, how much you'll be getting? 0.1. Okay, 0.1 into 6.023 into 10 to the power of 23. It is 22 what you'll be getting. So here 6.023 into 10 to the power of 22. Yes, into 3. So 3 ones are 3. Directly we can go for the answer. So 3, 6 are 18 like you will be getting. So you will get what it is, 18.069 into 10 to the power of 22. But here, let me write this also. 1.8069 into 10 to the power of 23. Can we write it in this way also? Yes. So the number of atoms present in 0.1 mole of triatomic gas, which is the correct option. So 1.8. Here what it is, 1.8069. 1.8069 actually into 10 to the power of 23. So option B is the correct option. Simple. It is what it is, easy way to identify. So triatomic gas, indirectly they have given the atomicity, number of atoms present in the molecule, that is called atomicity. Yeah, come on, let's go to the next question. The next question, 10 grams of hydrogen and 64 grams of oxygen were filled in steel vessel and exploded. Amount of water produced in this reaction will be. See, this is very simple. Previous question we have gone through. No, the limiting reagent, the same idea only. First and foremost, you have to write the equation, finding the number of moles, limiting reagent, and then finally you're getting the answer. Come on, first point, it is equation. So H2 plus O2, it gives H2O. So here what it is, 2H2 plus O2, it gives 2H2O. Yes, got it. So this is the equation. Now, number of moles, let us find out. So number of moles, what it is, given mass by molecular mass. So number of moles of hydrogen, that is given mass, what it is, 10 gram divided by molecular mass of hydrogen here 2. So how much you will get it? 5 mole. Right. Okay. Now number of moles of oxygen. So number of moles of oxygen. How much it is? 64 gram. It has mentioned very clearly. So 64 gram and molecular mass of oxygen here, what 2? 32. So here very easy. This is 2 mole. Right. Okay. So here now this is actually 5 moles of hydrogen combined with 2 moles of oxygen. Actually, what is the equation here? 2 moles of hydrogen combined with 1 mole of here 2 moles of hydrogen reacts with 1 mole of oxygen. It gives 2 moles of water. Right. Okay. But here what is the point they have given? 5 moles of hydrogen and here 2 moles of hydrogen, 2 moles of oxygen. Now, which is the limiting reagent? You yourself will identify. So, which is the least amount which is completely consumed? So, oxygen, it is a limiting reagent, limiting reactant, limiting reagent. Both of it. Right. Okay. So, here what it is? 2, generally, I'm coming to the point. So, 5 moles of hydrogen combined with 2 actually here, just 2 moles of hydrogen, 1 mole of half of that. So, that means 5 moles of hydrogen combined with 2.5 moles, right? 2.5 moles of oxygen only should come. See, here 2, here 1, and here 5 means divided by 2, here 2.5 only. But actually, it is completed by 2 mole only. So, this is the limiting reagent. Okay, come on. Now, I'm coming to the conclusion. So, it has to produce 2 here. Yeah, okay. 1 mole of oxygen can produce 2 moles of water. Where do we get 1 moles of oxygen? Here only. See, 1 mole of oxygen can produce 2 moles of water. So, that means 2 moles of oxygen can produce how much? 2 into 2. Here, 4 moles of water only. It is very easy. Like first thing you have to write that the equation, then number of moles because they have given what it is. Given mass, right? So given mass by molecular mass, that is very easy. And the next one, what it is? Finding that limiting reagent. And from that, we can compare both. So 1 mole oxygen can produce 2 moles of water. Therefore, 2 moles of oxygen can produce 4 moles of water. Come on, which is the correct option in this? 4 moles of water. B. Answer it is blinking. Yes, I am here for you to identify. Yes, this is the correct option. I hope you got a clarity about this point. Come on. The next question, 25.3 gram of sodium carbonate, that is Na2CO3, is dissolved in enough water to make 250 ml of solution. If sodium carbonate dissociates completely, molar concentration of sodium ion Na plus and carbonate ions CO3 2 minus or respectively molar mass, it is 106 gram per mole. Okay, now indirectly this question they are asking about what it is, molarity. Okay, strength of that solution, right? Come on, let us find that. So the data they have given, and even what it is, molar mass they have given. What is the data? It is given mass by molecular mass, so number of moles. So number of moles, number of moles of what? Sodium carbonate, Na2CO3. So Na2CO3, what it is? Given mass by molecular mass, right? So 25.3 gram of sodium carbonate divided by what it is, 106 gram per mole of what it is, molecular mass of given mass by molecular mass, right? So what is the answer? Number of moles only we have to identify. So number of moles here, when you are calculating, you will be getting 0.23238 mole you'll be getting, right? So the next point what we have to identify for, we have to prepare for molarity. So molarity, what it is, number of moles of sodium carbonate divided by volume of solution in liter. Okay, so molarity of sodium carbonate, so completely dissociates, no, it's nothing to worry. So Na2CO3, that is actually what it is, number of moles of Na2CO3. Just now we found right, Na2CO3 divided by volume of solution in liter. Volume of solution in liter. But here they have given what it is, ml. Make it liter, that's all. So make it liter means what it is. Here, just apply the data. Here, 250 only. Volume of solution, it is 250 ml. Volume of solution, it is 250 ml. So liter, how do we can calculate? Directly you can go 0.250 liter, right? Okay, just converted into liter. Okay, now can we apply the value? Molarity. Okay, so molarity equal to number of moles. Just now we found, no, so what it is, 0.2386 divided by volume of solution in liter, right? So 0.250, just 25 only you can put it. So what is the answer you'll be getting? Make it a whole number so that you will get 0.9546 capital M, molarity. What they have given, it is completely dissociates. So completely dissociates of Na plus and CO3 2 minus. I just mentioned here, completely dissociates. Dissociates. It is Na plus and CO3 2 minus. So Na2CO3, it gives Na plus, that is 2 Na plus. See here, 2 Na plus and CO3 2 minus. Yes, so that is 2 Na plus and 1 CO3 minus. Okay, now let us see the concentration. Here also we have to find the concentration. So concentration of Na plus. So concentration of Na plus, how much it is? Here actually what it is? 2, right? It is 2, right? So 2 into how much we have seen? Here 0.9546. So 9546, you make it a whole number here. That is 5. 3 numbers are enough. So 0.955 into 2. So how much you will be getting here? What it is? 1.91 m for sodium, and concentration of CO3, that there is carbonate. So concentration of CO3 2 minus, how much it is? 1 only. See here, 1 into 0.955. So you'll be getting 0.955 only. That is also M, right? M, capital M, capital M, right? Okay, now concentration of Na to CO3. Na plus is this much, and CO3 2 minus is this much. Come on, let us find the answer. 1.91 m and 0.955. Okay, now come on, let us find the answer. Yes, carbonate, what is this? See, that is actually here 0.955 m and 1.910 m. Here 1.91 m and 0.955, just ulta. See, it is very simple. So Na2, here what they have given, Na plus and CO3 minus, CO3 2 minus. So that means Na plus first and CO3 2 minus second. So Na plus how much? 1.91, right? And carbonate, it is 0.955. So option B is the correct option. Sometimes what we will think, so answer it is there somehow ulta, okay, we'll go for A option only. So actually, which is the correct option? I hope you got the clarity. Option B is the correct option. Why we have taken Na plus CO3 2 minus. See, this is Na plus and CO3 2 minus. This is what I hope. Come on, let's go to the next question. So option B is the correct option. Yes. The next question, which has the maximum number of molecules among the following? Here, 44 gram of carbon dioxide, 48 gram of ozone, 8 gram of hydrogen, and 64 gram of SO2. Right. Now, in this point, how do we identify given mass by molecular mass, that is number of moles? Okay, here molecules they have given. Now, I would like to give one the best point for you. So, the number of molecules is directly proportional to number of moles. Right. I'll mention that so that it will be easy for you to remember. So, the number of molecules is directly proportional to number of moles. So here, as one mole of any substance contains what it is? Avogadro molecules, right? Avogadro number, what it is? Avogadro number 6.6.023 into 10 to the power of 23 molecules, right? So this is moles and molecules, right? So this is a very very important point. Number of molecules directly proportional to number of moles, as one mole of any substance contains Avogadro number, that is 6.023 into 10 to the power of 23 molecules. Substance molecules, atoms means you can mention in that way moles, right? Okay, come on, atoms, right? Okay, now here number of moles we have to identify, no? So number of moles, you know that idea. So number of moles equal to number of moles equal to given mass by molecular mass. So here number of moles of carbon dioxide. Okay, so carbon dioxide, it is given mass how much? 44, right? Here 44 they have given, no? 44 divided by molecular mass also 44, you know very well. Okay, so here 1 mole, right? Number of moles of ozone. So ozone, how much? Here ozone 48 gram divided by, here also 48, 16 into 3, right? 48. So here also 1 mole, right? So you please note down the data so that it will be easy. 48 gram of ozone, 8 gram of hydrogen, 64 gram of SO2. So two more things we have to identify. So here ozone, next what it is? 8 gram of hydrogen. Okay, hydrogen how much? 8 grams of hydrogen divided by 2 molecular mass of hydrogen, H2, it is 2. So that is actually 4 moles. Right, now next one, the last one, here what it is? SO2. So SO2, what it is? 64 divided by given mass, it is 64 only. Molecular mass is, that is also 64. What it is? Here sulfur 32 and oxygen also 32 only, right? Oxygen also 32. So here 64. So here how much? It is 1 mole only. Now what is the question? Which is having maximum number of moles, right? So here, which has maximum number of molecules among the following? 100%. Here, number of molecules is directly proportional to number of moles, as 1 mole of any substance contains Avogadro number of that molecule. Okay, so substance means it is conclude it is a molecule. So which is the correct option? Option hydrogen, which is the hero of that what it is, periodic table, right? Yes, hope you got that idea. So option C is the correct option. C is the correct option. Yeah, C. Here it is a C. I just mentioned here it's a C, right? So C is a correct option. Hope you got the clarity and thank you for watching. Come on, next question in our next video. Till that, thank you. Yes.